Hi, welcome to Concept Based. I'm John Hepworth. This is year 11, trig equations and identities that we are looking at still. I'm a little bit ahead of the scope and sequence this year, so I'm just going to spend a little bit more time doing some questions. This is a past HSC question. This comes from the advanced 2020 past HSC. So if you want to save all of your past HSC questions to do them as past HSC papers, fair enough. I tell my students not to touch anything out of the last 3 years and then sit those ones as practice papers. So I'm going back 6 years here. So it's up to you if you don't want to see it, scroll on. Otherwise, here's a solution from a question from the 2020 HSC paper. I've picked this one because this proof's it's similar to the one that I did a few days ago, or a few videos ago, I should say, but it's a little bit easier. And I don't want to get bogged down in my channel where I only work on band 5, band 6 questions. Band 3, band 4 is just as important. We have a large cohort of students that are in those bands. So we need to be making sure that we're looking at questions that those types of students should be getting correct and, need hints and tips in that area. So if you're one of those students, this video is for you. So here's a trig proof. So again, it's a proof. So you need to really be across your algebraic skills when you're doing proofs. Often in proofs, something will happen with a power, or something will happen with a fraction, or you'll need to make a substitution, and you need to be comfortable with those sorts of things in algebra. So if you are being challenged by your year 10 algebra content still, then you need to revise that. Don't feel bad about going back to your year 10 textbook and doing that algebraic fractions topic again, or whacking into ChatGPT. Hey, please ask me some algebraic fraction questions and do 5 practice questions daily until you are really comfortable with fractions, because they come up everywhere and they're going to come up here in this trig proof. Okay, now looking at actually specific trig proofs, which side do I attack? So that question sometimes matters, sometimes doesn't matter. This question is actually solvable if I purely work on the left-hand side. It's solvable if I purely work on the right-hand side. And if I'm really struggling, I can work on the left-hand side a little bit and then work on the right-hand side a little bit, and then they end up looking like each other. Now, I would say a student who is struggling greatest and most challenged by these trig proofs probably would benefit from doing a little bit on the left-hand side and then a little bit on the right-hand side here, and not having to make any sort of big steps to get across to the other side. So I'm going to demonstrate that method here. Okay, so again, we're really aiming that for that band 3, band 4 type of style of solution. So let's go for that. Okay, now, please, if you're doing a proof, don't rewrite the question. They've written the question. The first thing we're going to write is left-hand side equals or right-hand side equals. It's a proof. That is what you have to do in your first bit of working. So let's look at left-hand side. Now it's hard to define whether I'm talking about a concept or a process. I suppose that this is a process. The process that I'm going to talk about is reducing everything to sine and cos if you can, and then reducing everything to just sine if you can, or just cos if you can. I suppose the concept I'm talking about is that simplification first can make the algebra easier, or make the trigonometry easier. Knowing what sec x is in related to tan x is challenging for some students. But relating sine x to tan x, well, tan x is sine x over cos x. That's much easier to have that recognition. So we're going to break everything down to sine and cos as much as we can and see where we get. Okay, so we're a student that struggles with trigonometry, and we see that in a proof it has sec x, and we're like, I can never remember whether that's 1 on cos or 1 on sine, or if it's even 1 on tan. Maybe you're forgetting that as well. Never fear, because there's a reference sheet. And on the reference sheet, there are trigonometric identities. Here it is. And I'm going to zoom in so you can see them. It tells you what sec is related to. It's 1 on cos. So because it's given to us, we can go ahead and make that substitution. So the left-hand side is going to be 1 on cos x minus cos x. Okay, so we got everything down to sine and cos. We haven't gotten it into one term, and we can see on the right-hand side there is only one term. So we could go ahead and actually make a next step and try and get it into one term. So let's do that. So this equals, now to get it into one term, we need the denominator to be the same as cos x. So this one over here, I'm going to multiply the top by cos x and the bottom by cos x. And now I'm going to put these two together and I get 1 minus cos squared x over cos x because I'm comfortable with my algebraic fractions. And then I might recognize something. Maybe you haven't, that's okay. Let's say we don't recognize something. Let's just say that's as far as we can get it. That's all we know. Excellent. All right, so now let's work on the right-hand side. So the right-hand side equaled sine x tan x. What we're going to do is change our tan down into sine and cos. So we get sine x times sine x over cos x. And so sine x times sine x is sine squared x. Now, if you are struggling with trig, you might find that something that's confusing. You might think of cos x as this different trig identity. It's not. It's just sine x squared, not x squared. We say sine squared x so we don't confuse it with sine x squared, but it really is sine x all squared. It's just the squaring of that expression. All right, so we've now got sine squared x over cos x. It doesn't really look like our left-hand side, 1 minus cos squared x over cos x. And that's because on our left-hand side, we only have, cos terms. And on our right-hand side, we've got this sine term. So we need to get, the sine squared term into the cos squared term. Well, back to the reference page for our savior, cos squared x plus sine squared x equals 1. So we can rearrange that to say that sine squared x is just equal to 1 minus cos squared x. We just make sine squared x the subject in that identity. And so we replace it with 1 minus cos squared x over cos x. And lo and behold, it looks like our left-hand side. And therefore, it's been proven as required. So that is definitely, like I said, there's at least 3 ways to do this question. Work on the left only, work on the right only, work on both sides. If you are using the minimize everything down to sine and cos and then everything into sine or everything into cos technique, then I would recommend working on both sides. If you struggle with algebraic fractions, work on both sides so you can try and get everything to minimize together and you're not having to manipulate things to look like something else. You're just constantly working down in this simplification sort of way. If you feel like you're up for a challenge, you could definitely try and just solve this by manipulating the left-hand side, or the trickier one in this case, just manipulating the right-hand side. You can solve it by just working on the right-hand side. Okay, there's a bunch of those types of proof questions. Don't just use obviously what's on this channel or what you get in your textbook. Snip a question, chuck it into ChatGPT or Copilot and say, hey, give me 5 of these types of proofs, and just work on them over and over. Maybe even give it in the prompt, can you make sure that algebraic fractions are included in these proofs? And so it will do ones that are a little bit more tricky in that way, like the one that we just did. When tan x is involved, usually a fraction will be included. If we're using sec or cosec, it's 1 over, so a fraction will get involved again. So proofs along those lines are going to help you.